Alright, in this lesson, we're going to learn about functions. So we're going to decide whether something is just a relation, or if it's specifically a function. I'm going to talk about what a function is in this video that you're watching right now, linked here. You're going to answer 6 questions about the functions, and then complete section 3 in your Cornell notes. Alright, so a relation is something that we've actually just been talking about for the last couple lessons. It's any set of x and y ordered pairs. These are all, this is one relation, it's the same thing over and over, but it's really just a random set of ordered pairs. There's nothing specific to it. It's just a set of points that we can plot on a graph, we can write in a table, we can put into a mapping, or we can write as a list of ordered pairs. A function is a specific kind of relation. It's still a set of ordered pairs, but it follows a rule. That's the important part. A relation can be random. It's just a set of points, but a function is a rule. And actually, to describe that, before I actually get into an example of it, I think a vending machine describes it perfectly. When I press A3, that should give me pretzels every time. Otherwise, this machine is broken. It's not really following a rule. It's not following its function. It's just doing something random. If I click A3, that should lead me to pretzels every time. If I hit A3 and I get water, this is not a function at all. It's not the vending machine's broken. It's not following its function. It's not following the rule. When that comes to numbers, it basically, actually I'm going to show this example first. This is the broken vending machine. If I put 9 in as an input, if I take 9 and I go to 3 some of the time, but then -3 other times, that is not a function. That is a broken rule because it's not really working. Anytime I put in 9, I should get the same thing each time. Otherwise, it's not really following a rule. It's kind of just random. So a function is a set of ordered pairs in which every x value has a unique y value. This goes to 1, this goes to 1, this goes to 1, this goes to 1. There is one line coming out of each of those. Otherwise, it would be the broken vending machine where I'm pushing a button and getting different things each time. It doesn't matter that I have 2 lines coming to this 4. That's still a function. You can click different things to get the same, that's not totally true in a vending machine, but you can have a different input and get the same output. But you can't have the same input and then somehow get a different output each time. So as long as there's only one line coming out of this side, that will be an input. Or another way to think about it is that if we don't repeat our x values, that's really what we're looking for. We don't want to repeat any of our x values in our ordered pairs. So that's what I'm going to be looking for in these 6 examples. I'm looking for if any x values repeat. I see in this first one, I have 0, 1, 2, 3, 4, 5. Those are all different x values. I do have repeating y values, but that's okay. I just can't have any repeating x values. So this is a good function. I'm not going to drag the thumbs up icon. I'm just going to put a check mark. That is a function. I'm going to go down to this table here. I see that I have a 1 here and here. So that's saying 1 goes to -2. And sometimes it also goes to 3. That doesn't work. That is not a function. That rule is not being followed all the time. Because 1 should only have one output. It shouldn't be going to 2 different numbers. I'm repeating this x value, so that's not a function. All right, looking at the mappings, the 0 goes to 1, 4 goes to 1, 7 goes to 3, 8 goes to 5, 10 goes to 5. I have one output for each of these inputs that is a function. Here, same thing. I really don't even care where they go. I know I have 2 lines coming to the 8, but that's okay. That's still a function. I have 2 lines coming to this -2. That's still a function. I'm really just looking, do each of these inputs have only one line coming out of it? And they do, so that is a function. In the top right one, I'm looking at each of my x coordinates. 2, 4, 6, 8. Those are all different. I really don't even have to look at the y values. I see 2, 4, 6, 8, all different x values. That is a function. On the last one, I see these 2 points, 1, 5 and 1, 7. 1 can't go to 5 and go to the 7 at the same time. That is not a function. That's not following the rule at all. So I have these 4 that are functions. The other 2 are just relations. They are all relations because they're all sets of ordered pairs, but these 4 are specifically functions. All right, there is a very easy way to tell on a graph. We're going to use something that's called the vertical line test. So it's really thinking about the same information. It's thinking, do we have an x value that's repeating and going to two different y values? So I'm going to show that here. The x value here, let's say that has an x value of 2. Let's say this has a y value of 2. This has a y value of -2. This point is 2, +2. This point is 2, -2. These 2 points are what I'm talking about. The x value is repeated here. That has 2, 2 as its ordered pair, so the x value is 2. This has 2, -2 as its ordered pair, so the x value is still 2. That is not a function. It does not pass the vertical line test. I'm imagining a vertical line sweeping over this graph, and if it hits 2 points at the same time, like we see there, it hits this point and this point, that fails the vertical line test, and that is not a function. This, if I pass vertical lines over this whole graph, it only hits 1 point on that graph each time. That passes the vertical line test, and that is a function. So you're imagining a vertical line sweeping across, and if it hits 2 points at the same time, it fails the vertical line test. Actually, I'm going to do this with this arrow here. Imagining this pass over the whole graph. It's hitting 1 point at a time. It's never hitting 2 points on that blue line at the same time. So that one is a function. I'm going to get this one. It hits that point. And then I keep sweeping. It hits this point next. And keep sweeping. And now I hit these 2 points. So that is not a function because it's hitting 2 points at the same time. These 2 points are stacked directly on top of each other, showing us that we really have that same x value of 3. This is 3, 3. This is 3, -4. These 2 points stacked directly on top of each other means that's not a function. I'm going to continue sweeping my graphs. That one gets hit there. That one gets hit 1 point at a time for each of these. And each point is just hit by that vertical line, while no other point is being hit by that same vertical line. So that is a function. This bottom right one is not a function. You can see right there. That point is getting hit. That point is getting hit by that same vertical line. So that's not a function. Those are 2 points that are stacked directly on top of each other. Same thing for this last one. We have a bunch of points stacked directly on top. This fails the vertical line test because we have 2 points that share the same x value. So this one is a function. That passed the vertical line test. This one is a function. These failed the vertical line test, not a function. Not a function. And not a function. If you have 2 points stacked directly on top of each other on a graph, or if you have repeating x values, then it is not a function. All right, one last example that I do want to talk about. Sometimes you're going to be asked to actually add points to this relation to keep it a function. So when I say I want to keep the relation a function, I basically want all different x values. So right now I have that. I have -2, 3, 1, 7. I have all different x values, so this is a function. I just want to add another point into this set to keep it a function. I want to keep this thing a function. So if I add 7, 0, that's not going to be a function because I already have a 7 there. I can't add an x value that's already existing in there. 6, 6. I have that y value of 6, but I don't have an x value. That's okay. I don't care about the y value at all. I don't have an x value of 6, so I could add that one. I said that I already have a 3 here, so I cannot add a 3, 14 to this ordered pair, a set of ordered pairs. I don't have a -1. I have a +1, but I don't have a -1 in there yet, so that's a different x value. That one's okay. I do already have a -2, so I can't use another x value of -2. So these 2 points, I could add and keep it a function. The other 3, if I add them, it's still a relation. It's still just a set of ordered pairs, but it's not a function because I have repeating x values.